Okay, and we're back. Excuse me. I have eaten food. All right. All right, so optimizing compilers allow us basically to focus on making the code, making it make sense, and not necessarily being the most optimal because it does those little low level optimizations for us. Trade offs. Maybe some levels will break your shit. Oh, true. Speed versus size. Oh, my ear's fixed, I think. Cool. Whether they do it, how much they do it, and what kind. How. How much and how. What type, I guess. Are we driving? What type of car are we driving? How fast are we driving? None. Oh, okay. Yeah, makes sense. Yeah, I want my debug build to disable it so I can make sure that everything's running as it is. The as if. However it likes. So long it does as it doesn't affect its observable behavior. Okay. One notable exception. Hmm. Oh, that's why it's because it's in here. Meaning this is an issue that the optimizations do, or they omit, even if it has observable behavior? No, the point is if they're unnecessary, and it can determine if they're unnecessary. So sometimes, if it determines that the observable behavior isn't needed, is unnecessary, then it removes maybe. Different techniques to optimize. Which technique depends on all the shit. Okay. Well, yeah, it makes sense. How do they do this if I don't know the result of this? I wouldn't pass it the sum of two literals. I would just pass it the result. could just do const, give it 7. Try some music. That feels wrong, but maybe it's just a different language. Hmm. Oh, so if I had any results where that calculation would happen during runtime, so like the 3 plus 7, all that kind of shit, the compile time optimizations would involve converting those things to values that are already known, if they can be known. So we don't have to do repetitive shit. Moving anything from runtime that we can to compile time. Which for gaming maybe makes sense, assuming that the shaders are so intensive that it creates observable behavior when loading. Maybe it makes sense to preload them all in the compile time, which is after the program has been executed, but before certain parts of the program that the user is interested in, the games, is executed or get executed. Yep. Yeah, makes sense. So what I was guessing earlier is called constant folding. So they fold constant expressions into whatever the result is. Makes sense. Sub-expressions, meaning this is an expression that returns this. Because these are operators, so these have to be operations, which are expression statements, it looks like. Full thing, so this is the sub-expression. Makes sense. Constant propagation, so propagate it. So replace it here earlier, maybe? Oh, so instead of storing this somewhere and then going there and then retrieving it here, it just places it here, I guess, maybe? So we've stored it in the memory, so we have instantiated a variable. Boom, this is your bucket. Put 7 in the bucket. And then on the next line, we go to the bucket, get the 7, and put it there. So we have to access memory to store something there, and then access to get the information there. To get the value there. Compiler replaces variables known to have constant values, which it does. This is a constant value, it's literal. Literal constant. Replaces them with their values. So it says, hey, this guy's pointing to this bucket, but the answer in the bucket's always the same. So how about this? Instead of every subsequent one having to go to the bucket and then getting it, how about we go to the bucket now in the compiler and during compilation, and then we just replace it all. So we have this guy and it exists, and then we just do that. We just replace the values so that this doesn't, we don't have to keep going here. To go out to memory. So from processing to go to memory to get something to come back to processing. Seven and 3, this guy's 7. So we're going to, this guy uses him, so this is 7, this is 3. Which then, these are 2 literals which can then be optimized by constant folding. Excuse me. Dead code elimination, meaning stuff that doesn't get run, it just gets removed. So you don't even need the conditional preprocessor directives then now, the macros. So here... Oh, we had dead code because we're not using X. I mean, granted, we would already get an error here because X not being used. Yeah. Yeah. It's been optimized out. Okay. Why would you say that? It's terrible. It's just a dumb way of saying it. There are people who say... If I say... No, man, my pet is a horse, dude. Johnny's a horse, not a fucking donkey. And then the person says, same difference instead of same thing. They're just talking stupid. Same difference. Same difference from what? What does that mean? Same for there to be a difference, there you have to have something that you're comparing it to. Same thing means horse, donkey. They're both things. The things they are, 4-legged, similar looking creatures. Same thing. The things that they are similar. Same thing. They're almost the same. They are the same. Same thing. Same difference. What do you mean? The difference between them and what they really are is small? So same difference? Like, that's just a retarded way of thinking. And speaking. Same here. Just like if I had said, my friend, my buddy, and I said, they thought this, instead of saying he thought this or she thought this. Like, why would you say they instead of he or she to add ambiguity when you know the answer to something? Makes no sense. So why would you say optimized away? You say optimized out. It's just faster. Makes sense. It's optimized out of the program. Out. It's not being triggered. It's not away. Away is like, oh, she's far away. Meaning, she's not gone. But in this case, it's gone. It is not run. It is removed. So if I'm If I broke up with my ex, yeah, I broke up with my ex. I didn't move away from her life. I moved out of her life, yo. Yeah, true. We don't need to... Well... Oh, you mean compared to the original version? Yeah, 1, 2, 3. Well, this would be 4, but here, if you're talking about 1, and then if this was X, 2, yeah.
Sure, I'd like to get into the computer field, but hey, what's the hurry? I can always start my training tomorrow.
To learn how you can train to become a computer programmer, operator, or technician, call Control Data Institute now, before tomorrow passes you by.
You're saying compared to the original version, original version. Yes. So it turns out, oh, you're meaning, yeah, so from the original, we can use constant propagation. So we see that this guy, well actually, well yeah. So we could see that this was X, here's X. Constant propagation. This guy's a constant. This guy uses him. Replace this guy with his value. But now, he's not being run. Excuse me. Once we've compiled, we've built this program in its translated source code way that has been optimized. So this literally reads like this now instead of X. This does not run anymore. It's gone. So, dead code elimination. Alright, makes sense. We've optimized the whole thing out via constant propagation and dead code elimination. No constant folding here, though. Well, actually, in the beginning, it was 3 plus 4. So we did constant folding. And then we realized, it realized, oh, hey, this is a constant value for this. It doesn't change. So then we do constant propagation. And then we do dead code elimination to remove it. So we've folded the two constants into one. But then that constant has its own, has one value and it doesn't change. So we just replace subsequent references to it with its value. And then this is now dead code, so we remove it. True. Yeah, smaller because it's been compiled. Or once it's built, I guess. Or packaged. So instead of making the compiler have to realize when something doesn't change by looking to see if it changes, we could say constant to just tell it from the get-go. Yeah, so my gravity using ball falling from a tower position calculating program yesterday from the quiz about data types, I guess, and conditions. Conditionals. Could have had some constants. One would be the tower height Another would be gravity. Maybe another could be time. Yeah. It's a constant times a constant, which is fine. Divided by 2 is just in the formula. Yeah. In order to do it, it must realize that it doesn't change. Even though it could change, but it doesn't actually. So it says, oh, this could change. Let me check to make sure it changes, or it doesn't change. And let me check to see if it does. Ugh. Excuse me. The program is complex enough, it won't even be able to realize that maybe. So const makes sense. Probably more important too for real, like, larger objects that aren't the fundamental types. Because it's not guaranteed that it'll go and do all these things, because depends on the complexity of the program and how aggressive the optimizer is optimizing. But now it sees, oh yo, shit definitely doesn't change. Replace him with 7. This is replace this. All references of him with 7, and then he doesn't run, so dead code. Remove him. Oh yeah, makes sense. Yep. Okay. Makes it faster when it optimizes. Oh. Yeah, true. Yeah, because then things look like magical values. You don't even see the code. So, yeah. Oh, true. Yeah, the compiler basically says magic values are removed for humans to understand, but if the compiler says, yo, gravity is always 9.8, replace gravity with 9.8, replace all references of gravity with 9.8, remove the code for gravity being initialized, just plug in the magic values everywhere. But then if I go to my program and I was watching it actually run, and I was getting debug information from the run, the ran the ran fast version, the compiled version, then if I'm trying to watch a variable to see what's going on, but then, especially if I'm expecting it to change, but it realized it didn't change and then optimized them out, I'm not even going to see a response for the variable, yet the program will still be working. It'll look like it's exhibiting undefined behavior, but it's not. Yeah, true. The function's been optimized away. Let me check something real quick. Oh, fuck. Ugh. That's annoying. I had a fucking tonsil stone in the back of my throat, and I have a mechanical pencil that I wash off every time it's clean. And I just poke around there to like nudge it out. But it was far back, and the left side is harder to get into, and I have a worse gag reflex there. Because I don't really get tonsil stones there as much. I get them like once every maybe a few times a month. Sometimes a month without any. But they're usually on the right side. Sometimes they're on the left, but they're usually easier to get out. But that one was hard. I think I got it. But I was trying to check to make sure I did. And then I gagged. And of course I just fucking ate. So of course I threw up on accident. So, good. But it was before it was digested. There was no stomach acid or anything. It was super, super high up on my stomach. So I got fucking lucky. Yeah. No acidity. Teeth are fine. Thank God. I hate that feeling. I hate the acidic damage of the back of the throat. Because apparently dentists can tell pretty easily. One, by teeth being fucked up, but also by your throat being bruised from vomit. If you're one of those weird ass bulimics or something. Oh. I hate that I've gotten so good at feeling whenever there are tonsil stones. I can just tell. Yeah, if I'm watching the value or the variable, but the variable isn't even there anymore, or the value's fucked up, and it's obviously behaving different than the source code says it should. Could be optimizing. Yeah, exactly. Oh, GG's. Yeah, that's what we would want. Yeah, the value is determined at runtime. So he's not a constant yet. The compiler's optimizer might realize, hey, he's constant, but he's not literally a constant. These are compile time constants. These are constants. His values are known at compile time. Runtime constants. Sure, these are constants, but the values are determined at runtime. The compiler might figure it out in the meantime, but it technically isn't known until runtime. It might be able to do this. Figure this guy out. Do a little bit of that constant propagation. Yeah, right? Oh. So even though this is a compile time constant, it can't be used in compile time features? Really? Guess we learn that next. Constant expressions. Oh. Evaluate at runtime. And in some cases, they have to evaluate at runtime. They're not allowed to do stuff at compile time. Yeah, I mean, we can't get output before we get output, so. Alright. Can't get input, rather. Oh yeah, and we can't do output at compile time either, so. These must be evaluated at runtime. Excuse me, this should just say must evaluate. Must evaluate at runtime. Must should be this. Yeah. Yeah. Constant folding here. Well, it's actually constant propagation, then constant folding. Propagate. Propagate. Fold. Dead code removal or something. Code deadening. Here we go. Constant expr. Oh, there's a const expr variable. That's not a CV, it doesn't look like. Hmm. And so by default, this would be error. Right? Yeah, see? Because it needs an initializer. It must be initialized at compile time. It's only been declared. It's technically been defined, but... and declared. Const expression. Okay, one more chapter. Yep. Cool. Who? Who? Maybe. Man, there's nothing. There's fucking nothing right now, dude. Damn, we learn arrays late. That's crazy. Wonder if we learned. I think we learned pointers before. Sounds like we learned to do some crazy shit before even learning how to store multiple values in one variable. But so far, I feel like I have a pretty good grasp about how everything I know does everything. So. Yeah, makes sense. Yeah. There's subjectivity and ambiguity. We don't necessarily know exactly what will be optimized. Yeah. Yep. Jesus. Yep. Yep. Compile time programming. Makes sense? Oh, so using compile time programming to make code that always executes at compile time. Well, yeah. Sounds like we use certain features to make use of other certain features? Ow! Popped a pimple on my back. Ow. So for code that we want to execute at compile time, there are specific features we can enact so that even if the compiler changes, I'm not going to just adopt the new language standard. That's not going to automatically be updated. It's determined by the program, motherfucker. So the program will still work because we have opted to use code excuse me, that runs at compile time, or is evaluated at compile time. Oh shit. Evaluate means the taking of a value from something. Evalue. Wow, I didn't know that value was in evaluate. Yeah, so if we optimize or if we create things in such a way that everything is done at compile time using the shit that we've got, or using the language itself, using features in the language that remove ambiguity and stuff from the implementation, then even if the implementation changes, we're still good to go. Which honestly makes it more predictable. Oh, okay. Yeah, it makes sense. Okay. So if there are things we want to execute at compile time, we can use compile time programming to check and make sure that it will execute at compile time. Because if the parameters and shit don't line up, then it sounds like it probably won't execute at compile time. Yeah, makes sense. Do more things so that it's ready at compile time, and build it in such a way that it handles errors at compile time and reports things accordingly. Boom. Undefined behavior is not allowed at compile time because it's based on the compiler, not... Well, implementation's the system, but... Yeah, I guess the compiler... Oh, motherfucker, dude. I wish this headset was wireless. Too hot. I wish I could just toggle the glasses on and off, man, without having to take them off my fucking face. God. I wish I could just tap and we're good. And then tap and then walk around. God, I fucking hate this. Yeah, it sounds like if we have stuff executed compile time, and we have errors enabled in a high warning level, or a warning says errors enabled and a high warning level, then undefined behavior should maybe get caught by the compiler. But it might not get everything. Makes sense. Holy long. Yes, we're using extra features. Make safer, better, faster programs. Well, fuck it, dude. Sounds good to me. Hmm. So make all expressions constant expressions. That way they have to evaluate at compile time. Or make as many as I can. Make all that I can. Do it. Make all that I can. Constant expressions. Hmm. So no unknown variables. Non-constant expressions are constant and non-constant expressions or runtime expressions. Oh yeah, because it's compiling and interpreting. So we're converting it live or converting it all at once, I think, something like that. Or no, interpreting is just interpreting the values there rather than translating it to source code, something like that. Alright, it's 11, time for game dev time. Tomorrow we continue with constant expressions. Okay. Alright, game dev time.